Whenever we need to study it in parts, in sections. One was we can study our data within certain intervals. So empirical rule says whenever the distribution is bell-shaped or normal, approximately 68% of the data values fall within one standard deviation of the mean. Approximately 95% of the data values fall within two standard deviation of mean. And approximately 99.7% of the data values will fall within three standard deviation of the mean. So what is the meaning of one standard deviation of mean, two standard deviation of mean, and three standard deviation mean? Actually, in nature, all the things cluster about the mean value. Even we in manufacturing process, in construction, we put certain criteria, but we don't have always all the things just according to this criteria, the given criteria, or you can say according to the specification. They will have some difference. They will fall although near to that criteria, but not exactly equal to the same prescribed measure. So in this way, all the things fall near the average. When the situation is extraordinarily high, it cools down, always cools down, just like temperature, weather condition. If the temperature is very much low, slowly it will rise, because there is a tendency, always a tendency towards the average. So in this situation, in this diagram, also we have the things clustering along the mean value. Here we have the mean value. Either this mean value is of the sample data, or even if it is for the population data, even then all the things will fall near the mean value. How much they are clustering? Maybe sometimes they are away from the mean value in a larger way, and sometimes they are too much closer to the mean value. So how to observe them? We will move on the left and right side and draw certain intervals and observe now how much the data is falling within this range. So this also happens in generally in all the cases, that if we subtract one standard deviation from mean value, we are here, and if we add S or sigma, one standard deviation, we are here. So this is called one standard deviation interval. It always contains approximately 68% of the data. Now if we subtract 2s from mean value, we are here, and by adding 2s to this mean value, we are here. In this way, we have this interval, and it contains approximately 95% of the data. Similarly, by subtracting 3s, we are here, and by adding 3s, we are here. So a larger interval, which we call a 3 standard deviation interval, it will contain almost all the data, 99.7% of the data. So it happens only in case of a bell-shaped distribution. This is a bell-shaped distribution with a single peak. A statistical curve is a bell-shaped curve. So in this case, approximately 68% of the data will be contained in one standard deviation, 95% in two standard deviation, and approximately 99.7% in three standard deviation of the mean. Again, here we observe two things. We are constructing these intervals by one standard deviation, two standard deviation, and three standard deviation. This is a little restriction. Moreover, remember that these intervals contain approximate data, approximately 68%, approximately 95%, approximately 99.7%. So remember, in case of empirical rule, we have approximate percentage. Now again, look at this empirical rule. We are dealing with a percentage and an interval. So in our problems, either we have a percentage and need to calculate certain interval. Sometimes an interval is given. We will calculate the corresponding percentage of the data contained in that interval. For example, we have a data which is bell-shaped. Bell-shaped means normal, with mean 69.6 and standard deviation 1.4. About what proportion of the data is between 68.2 and 71. So a range is given. Remember, this range is about the mean value. Mean value is in the center of this range. Okay, and we need the corresponding percentage. At the moment, we don't know that this interval is one standard deviation, two standard deviation, or three standard deviation. As we come to know this figure, then easily we can state the percentage of the data to contain in this given interval. Okay. Generally, now equate these limits, left hand with x bar minus ks 68.2 and right hand limit x bar plus ks equal to 71. Putting the value of x bar and s is standard deviation which is given in the statement. So we have this equation 69.6 minus k 1.4 equal to 68.2. Solving this equation, we get k is equal to 1. Similarly, solving the second equation, we again getting k is equal to 1. So this means this interval is x bar minus 1s, x bar plus 1s. This is one standard deviation interval. One standard deviation interval. So by empirical rule, a one standard deviation interval contains approximately 68% of the data. In part B, in part B, as the distribution is bell-shaped, so we can apply empirical rule. And a certain percentage is given. So again, by empirical rule, 95%, approximately 95% of the data is contained in two standard deviation of the mean. And this interval is x bar minus 2s and right hand point is x bar plus 2s. Or we can also express this interval with x bar plus minus 2s. Okay, we need to find out these limits. So x bar minus 2s is 72.4. X bar minus 2s is 68.8 and x bar plus 2s is 72.4. So this interval from 6.8 to 72.4, it contains approximately. We use the word approximately for empirical rule. So in this way, we have answered both the parts. So we have a difficulty in these problems whenever we don't get the same value of k when we solve these equations. For example, an interval is given So we equate the limits of the interval with x bar minus ks and x bar plus ks, and solving both the equations. And we get different values of k. For example, if these limits are given 68.2 and 72.4, by solving the equations, one equation we get k is equal to 1, and by solving other equation we get k is equal to 2. K is equal to 1 means we have one standard deviation interval and corresponding percentage is 68%. For k is equal to 2 means we are having two standard deviation interval and it contains 95% of the interval. So what should we do? Let me observe these things in an example. We have this situation. For k is equal to 1, we have this interval. From x bar minus s to x bar plus s. The values of x bar minus s and x bar plus s are 68.2 and 71. Okay. For k is equal to 2, we have this interval from x bar minus 2s to x bar plus 2s. The value of x bar minus 2s is 68.8, 66.8 and 72.4. But we are given these limits in our question. These limits are given. So we need actually the percentage of the data falling in this range. We need only this data. This means left half of the smaller interval and right half of the larger interval is considered. As we know that one standard deviation interval contains 68% of the data. So this gray shaded part is 68 by 2. And also we know that two standard deviation interval contains 95% of the data. So this right half of this interval is 95 by 2%. So this is our answer. 68 by 2%. 68 by 2 percent, and this shaded part is 95 by 2%. Add both these percentages. This is our required answer. So half of 68% and half of 95% is added. So finally we have approximately, remember when you apply empirical rule, always you have approximate data. Now if we have other than k is equal to 1, k is equal to 2, we are getting here in this case the value of k different from 1, 2 and 3. Then how we find the corresponding percentage? We calculate this percentage with this formula. This happens in Chebyshev theorem. When the distribution is not necessarily normal. So this one is a general case. It works also for normal distribution and also non-normal distribution. So what is the statement? That at least 1 minus 1 over k square percent of the data will fall within k standard deviation of the mean. K standard deviation of the mean. What is the meaning? That is the interval x bar plus minus ks. Say x bar minus ks and right hand limit is x bar plus ks. Interval will contain at least one minus 1 over k square percent of the data. Of the data. Where k is any positive whole number greater than 1. Remember in this case, the value of k is greater than 1. There is also a little difference between empirical rule and Chebyshev theorem. One is of the normality, that empirical rule works only for bell-shaped distribution or normal distribution, whereas Chebyshev theorem works for all types of the distributions. But there is an other important difference. It contains approximate percentage of the data, but in this case, the interval contains at least percentage of the data. We will face this situation. For example, in this problem, our sample size is 50 with mean 28 and standard deviation 3. So what percentage of the data will be contained in this interval from 22 to 34? So equate both the limits with the general expression of the interval that x bar minus ks is our left hand limit and x bar plus ks is our right hand limit. Solving both, we have k is equal to 2. So as in this case, this is not mentioned that the distribution is bell-shaped or normal. So we deal with the Chebyshev theorem. As we are getting k is equal to 2, so 1 minus 1 over k square percent means 1 minus 1 over k is equal to 2. So 1 over 4, 3 by 4 and 3 by 4 means 75% of the data values. Data values are 50. So we calculate 75% of 50. That is 37.4. As we are counting the number of values, so 37.5 means 38 values will be contained in the given interval. And this one is at least percentage. Again, in this case also, if we don't have the same values of k, so use the above technique. Consider half of the percentage corresponding to each value of k. So for the practice, try these questions also. Then we have skewness and kurtosis. That is again a descriptive analysis. How the distribution is. 1 minute, please. So in this descriptive analysis, we can describe the shape of the frequency curve without tracing it. Because all the time we cannot trace out a frequency curve due to lesser information. So a distribution, a frequency distribution, a frequency curve is normal and symmetrical like this. Either it is with this shape or it may be like this, or it may be of this form. In this study, we have a certain advantage to describe our data. If we could find out this measure, and come to know that the distribution is normal and symmetrical. So in this case, the mean, mode, and median will fall at the same point in the center against highest peak. So this is an important advantage for further analysis. Okay, when the things are not symmetrical, they are skewed. Skewness is an opposite word of the symmetry. When the distribution is not symmetrical, it will be skewed. Maybe skewed to the right. This is called positively skewed, and maybe the data trend is towards the left side. So this is called negatively skewed. In this case, what happens? What is the conclusion? In this situation, mode is here against the highest peak. Against the highest peak, the point on the x-axis is the mode. And here we have the mean value. And